This is important. Laplace transform of derivatives. Laplace transform of derivatives. Using, how should I use this derivative concept in Laplace transform? What is the use of the derivative in Laplace transform? Means, suppose if you want to calculate the formula, then by according to derivative, how should I get that formula? Theorem statement. Laplace transform of derivatives. This is concept name. Laplace transform of derivatives statement. If f of t is continuous and exponential order. Now already I explained you continuous and exponential order, the previous definitions, and just you focus on the formula only. According to that formula we will get the answer very easily. And f dash of t is sectionally continuous, means piecewise continuous. Sectionally continuous means piecewise continuous. Then Laplace transform of f dash of t. F dash of t means first derivative. F dash of t is given by Laplace transform of f dash of t equal to s into f bar of s minus f of 0, where f bar of s is Laplace transform of f of t. This is the statement of the Laplace transform of derivatives. And general statement, once again, this is the only I am talking about first derivative. If you have second derivative, third derivative, then what is the formula? Laplace transform of f power n of t means f power n of t means nth derivative of f of t, means n times derivative of f of t. The formula is s power n f bar of s minus s power n minus 1 f of 0 minus s power n minus 2 into f dash of 0 minus so on minus f power n minus 1 0. Here observe this one, f dash of 0, f power at last f power n minus 1 of 0 means n minus 1 times derivative of f at 0 value, means at t equal to 0. Then Laplace transform of f of nth derivative of f of t equal to s power n into f bar of s. If f of 0 is 0, f dash of 0 is 0, f double dash of 0 is 0, everything, every derivative at 0 is 0, then this is the formula. Then according to these two formulas, we can solve the problems very easily. Based on this concept, we will try to solve some problems, one or two problems. Try to understand the concept. Then first example, using the theorem on transform of derivatives, find the Laplace transform of the following. First question, e power at, second function cos at. Second question is cos at. Then you know very well what is that Laplace transform of e power at from basic definition, 1 by s minus a. But what they are asking, using the theorem on transform of derivatives, Laplace transform of derivative, using that concept you have to create Laplace transform of e power at is 1 by s minus a. That you have to understand the concept. Then observe this one, you know very well the theorem formula. First statement, first derivative, Laplace transform of f dash of t equal to s into Laplace transform of f of t minus f of 0, means actually s into f bar of s, s into f bar of s minus f of 0. What is that? Laplace transform of f dash of t equal to, but f bar of s is nothing but Laplace transform of f of t. I am writing here s into Laplace transform of e power at f of 0 value. What is that? F of 0 means f of 0 equal to f of t equal to e power at. Am I right? I am writing here f of 0 is 1. That's why s into Laplace transform of e power at minus 1. Then what they asked, Laplace transform of e power at. Then focus on Laplace transform of e power at. Here observe this one, both functions are available. Then you bring this side, a into Laplace transform of e power at. I am sending this term this side, minus s into Laplace transform of e power at equal to minus 1. I am putting RHS side minus 1. Then Laplace transform of e power at, Laplace transform of e power at, I will take the common, then I will send that side, minus 1 by a minus s. Then it becomes 1 by s minus a. means finally what I got, Laplace transform of e power at is 1 by s minus a. You know that formula, Laplace transform of e power at is 1 by s minus a. But using this concept, I am creating Laplace transform of e power at is 1 by s minus a. This formula also we are using in rare cases, but you understand the concept. Then while solving the problems, how to apply this concept? We are getting very minimum problems, 5% problems, 1 or 2 problems we are getting, not 5%, 1-2% problems we are getting, right? Don't worry about this concept. And just what I am doing here, we are creating Laplace transform of e power at is 1 by s minus a by using Laplace transform of derivatives. Now in the same way, I want to create Laplace transform of cos at. You know very well what is cos at, formula s by s square plus a square, formula is. Then how should I get this formula? By using this concept. Now f of t equal to cos at, then I have given. Then f dash of t is how much? Minus a into sin at. Am I right? F dash of derivative of cos at minus sin at, the coefficient is a, minus a into sin at. F double dash of t equal to minus a square cos at, because cos at I need formula once again, that's why I am doing here cos at. And here according to first derivative we won't get the formula, because here cos is available, here sin we are getting. That's why I am doing one more time differentiation. F double dash of t equal to minus a square into cos at. Now you apply Laplace transform of f double dash of t. What is the formula? Laplace transform of f double dash of t is, what is that formula? The general formula I have given, wherever n is there, n is 2 here, s square f bar of s, am I right? Minus s power n minus 2, n is 2 means s power 2 minus 1 is s into f of 0 minus, again 2 minus 2 s power 0 is 1, f dash of 0, right? F dash of 0. Then f of 0 is cos 0 1, f dash of 0 is minus a into sin 0 is 0, right? Now substitute all these values in above formula. Laplace transform of minus a square cos at, f double dash of at means cos at, equal to s square, f of t means f bar of s is nothing but f of t, Laplace transform of cos at minus s into 1. S into 1 means s into f of 0 value is 1 minus f dash of 0 is value is 0. Then what I will do, I will underline these two, I am underlining these two parts. Just you bring this side, a square plus s square plus a square equal to Laplace transform of cos at, then s is that side. Then minus taken, I have taken common, that's why we are getting like this on simplification. You focus on, I want to calculate Laplace transform of cos at, that's why I have taken Laplace transform of cos at equal to s by s square plus a square. Like this, nothing is there. By using Laplace transform of derivatives, we are creating the formulas, we are constructing the formulas. Laplace transform of e power at, that is 1 by s minus a, Laplace transform of cos at, that is cos at is s by s square plus a square, like this.